flash by.
Afternoon, YouTube. Back with you once more. I want to try to explain this test I did yesterday a little bit better than I did. What you're looking at here is the circuit diagram for the Heathkit IM13. You'll notice that there's two areas outlined, one in orange and one in green. The green, as you can see by the words there, it's 2 meter circuit. That's the first test I did. That's the one I was showing the meter moving back and forth and how smoothly it went back down to 0. That's the part I was doing there. And the other part, the part in orange, is the voltage divider circuit, and that was the second test. And we saw that it did in fact take a while to go back down to 0 on the meter. So we're going to assume the problem is in that area there. So what I want to do is break this down a little further for you by looking at the individual circuits as we would look at them closer here. Let me get this set up here. Okay, this is a close-up of the green section that I outlined just a second ago. This is a 2 meter circuit. You can see the 12AU7, and you see the on the left, the pin number 2 goes to a 3.3 meg ohm resistor. That's R12, and then from there it goes on to the voltage divider section. That's where I cut the line yesterday. And I cut the line, and then what I did was, I cut the line, and I put in a 10 meg ohm resistor across that. And as you look at this next picture here, you can see that the tube circuit is now balanced. It's the same on both sides, and the only thing that makes it change is the zero adjust down there on R33. If you move it one way, it's going to go the balance will be the other way, and the meter, the needle will move on the meter. And to get it to 0, we adjust that zero adjust to where it's on 0, and then any changes made to the voltage on either side of that tube will cause the meter to move one way or the other. Okay. So if we consider that, both of the plates on the top, the pin number 1 and 6, are tied together, and they're at 60 volts DC potential. Okay, so they're equal, and once you adjust the zero adjust, the cathodes, pin 3 and 8, will be equal, and with the same exact circuitry on pins 2 and 7, the grids, those are equal. So that is what you call a balanced tube. It's between each side of the tube, it's completely balanced. So what we're going to do is take a battery, just like I did in the test yesterday, and we're going to apply the voltage across that resistor on the left side, pin 2, and each time I touch that, you notice that the meter went up. I just got lucky on the fact that that's what it took to make the meter go up full scale, but that's what worked out. And each time I released the battery, the meter would fall back down to 0, no problem. And so that's what we were doing with that circuit. And you can see that the two capacitors, as I was talking about, they're little disc capacitors, C4 and C5. That kind of rules them out as suspects in that stickiness, whatever you want to call the delay it takes to get down and up and stuff like that. So that way we completely eliminated this part of the circuit, as the problem area. So next what we want to do, let's see what we got here. Yeah, that's it. Next what we want to do is look at the voltage divider section.
Touch mine.